Hello. Thank you very much for coming to this session about progressive delivery in the Kubernetes era. Probably most of you already know what is Kubernetes. If not, no worries. It's just, writing a bunch of YAML files, do kubectl apply, and just works, right? So no. My name is Alex Soto. My Twitter is Alex Soto B. My email is soto@redhat.com. If you got any question, I know that we've got this platform. You can do there questions. But if it comes later, you can ping me in Twitter or by mail. And also, I'm the co-author of all these books. First of all, we know that today we're going to see a bit of what is progressive delivery, some delivery techniques, Kubernetes, and finally, the conclusions. Basically, why this talk? Well, because your code has only value when it's in production, right? Production is the best place where your code should be, not here in Disneyland, right? In your laptop. That's fine to be there, but it's not producing any value. So at least you need to move your services, your application to production at some point, right? I would like to ask you, who is under 40? Under 40? Okay, now please don't be scared, because in the past, we had all this pipeline with continuous integration and continuous delivery, and then we get, okay, I just do all these steps that probably most of you already know or you're already practicing, and then it's time to deploy and release to production. How we make this move? So all of you that are under 40, as I said, don't be scared, because in the past we did like this. We've got an FTP server, and we just grab, or WAR file or jar file, and we copy it manually to one special directory called maybe libs, web apps, or whatever it's called in Tomcat, JBoss. Then, with the time, we said, yeah, but now we are doing better, and we're using rsync. Which, okay, it's doing terminal and so on. Yeah, I know that some of you have said, no, I've never worked in that way, but I work in that way because I'm... And then probably most of you say, oh no, but now we are in Kubernetes and we are using kubectl, right? To deploy to production, we use kubectl. But sorry about that, but using kubectl, it's exactly the same thing as if you were using rsync or FTP. It's just, getting to production servers and apply something. So we need to find some better ways to do that. And it's not only about moving the pieces from one place to production, it's how we move these pieces of software, how we make our traffic goes to these new places. And this is exactly what is progressive delivery about. Basically, with progressive delivery, it's the last part of the continuous integration and continuous delivery pipeline, where we are just making our application or service available to all our customers or to all our public traffic. One of the great things about progressive delivery is that they try to promote no big bang releases. So it's not anymore this kind of, just deploy the new version, done, and let's see what's happened. Progressive delivery tries to not promote this. And they can do because we are making a difference between deploy and release. And that's really important, because in the past, we were thinking like deploying something to production was exactly the same thing as releasing something to production. But that's not true. Nowadays, deploy is just moving something into production. For example, spawning a pod. So when we boot up a pod in your production server, you are deploying your application. But then there is the release part. The release part is start sending public traffic to that pod. Okay, you can see that you can deploy a lot of things in your production cluster, but only releasing a few of them. What is really important about progressive delivery is having a really good metric system. Because if you do not have a really good metric system, you will not be able to detect if there is any failure, or detect if it's performing as you were expecting. And another thing that you might see with progressive delivery is that you are not releasing all your new application to all the users, but only into a subset of users. So you're going to choose a small subset of these users that are special for any reason, maybe randomly chosen, and we're going to start sending them to the new version and see how this application behaves. Okay, so one of the great benefits of progressive delivery, as you can see, you are decreasing the downtime. Okay, because if you can start testing slowly your application in production, probably you're not going to have downtimes because you still have the old version, but also the new version, so there is no downtime at all. Of course, you are also limiting the tragedy. What's happening if you deploy a new version and the new version just fails? For any reason, maybe there's a bug, maybe there's a regression, whatever. Since you are not doing a big bang release, you're not releasing your application to everyone, just in a small subset of users, you're limiting the tragedy. Only this small subset of users will get the failure. And finally, with the time, you will see that you're going to be able to put to production faster your applications, your services. So, let's talk about these delivery techniques, these progressive delivery techniques that let us, as the name suggests, deliver our applications progressively to our users. And of course, there is a lot of techniques. I'm going to just explain some of them, the most used ones, but if you Google a bit, you'll see a lot of them. The first one, this is a quite old, right? Because it was invented when we were using virtual machines. Basically, it's the blue-green deployment. It's like, okay, I've got my version 1, which is here. Then I deploy the version 2. So you can see that the version 2 is on production, but it's not getting any traffic. And then at some point, we decide to release version 2. So we take our router and change, instead of pointing to version 1, pointing to version 2. That technique was really useful when we got virtual machines, because the blue was one virtual machine, the green was another virtual machine, and then we can just get back, from one version to another version, from one virtual machine to another virtual machine. As you can see, it was all or nothing. So it was like, okay, now it's V1, and now it's V2. All the traffic goes from V1 to V2. One of the big improvements of this technique, but it was that if you detect any failure on the version 2, you were really quickly moved to version 1. You just needed to change the routing rules, because you are not destroying the virtual machine when you switch to V2. You still have both versions running. It was cool, it worked, but as you can see, it's like, okay, yeah, it's all or nothing, so there is some downtime. So then they created another progressive delivery technique, which is canary releases. It's more or less the same thing, okay? But instead of moving all the traffic from version 1 to version 2, what we are doing is starting doing percentage. For example, you say, okay, now randomly I'm going to choose 10% of the traffic, and I will send it to version 2, and 90% of the traffic will remain to the version 1. So we are fine. We are sending this. If version 2 works, great, let's increase this percentage. Now we're going to do 80-20. If everything works as expected, 50-50, and so on, until you end up by moving all the traffic to the new version, to the version 2. Okay? What is really important here is that you need to have a good metric system to detect if you want to increase this percentage or not, because at the end you need to decide. You have 90-10, you want to move to 80-20. Okay, you need to define when are you going to increase this percentage. And this why or when or what we are going to do, it's something that you need to define before you apply this technique. Then there is another technique here, which is named dark launches. Dark launches is like an umbrella of techniques that let you test your application in production without the end users noticing it. So basically, you are making your users testing your application. And as you can see here, there is a lot of different techniques. One of those is mirroring traffic. Mirroring traffic basically is that you've got here version 1. You can see here the arrow, which is bidirectional. It means that I'm sending requests to version 1, and version 1 produces a response, and I send back this response to the caller. But at the same time, I'm just here sending also a request to the version 2. But you can see that the arrow is not bidirectional. It's a fire and forget request. So basically, I'm sending the request, the same request to the both services, and then I'm monitoring the both services. I can compare the results. I can compare, for example, the performance. Of course, users will still always receive a response from version 1, but you are also testing version 2. When you are fine with this and said, oh, it seems that it's going to work, then, for example, you could start canary release process. There is another one, which is dark canaries. Dark canaries, it's the same as canary releases, but you choose the users instead of randomly by an attribute. And this attribute could be anything. I will explain you now an example, but in this case, I'm just saying, look, if I've got a, for example, HTTP header, name it test equal true, then send the traffic to the version 2. If not, send it to version 1. So you can see that depending on the environment of the headers, I'm sending traffic to one version or another. And this is really done by Facebook. Facebook, when we, if there's anyone here that is from Facebook, then it's on the other side, but we are not working in Facebook, when we access to Facebook, we are accessing one version of Facebook. But if we are employees of Facebook, what Facebook does is saying, oh, you're a user, and in your email, you've got @facebook.com. It means that you work for Facebook. So I'm not going to send you to this version. I'm going to send you to a newer version of Facebook. So you are starting testing the version that we're going to release maybe in 1 week, right? So this is something that you can do with dark canaries. And then, of course, we've got also feature flags. Feature flags, yeah, probably most of you already know. It's for me, it's not the best approach, but basically it's that you can put some of your code into a conditional, and then you can enable or disable this condition more or less dynamically, okay? It's something that it's easy to implement, that's true, but you tend up to, end up with a really complicated code. But let me tell you one thing, and don't tell this to your manager. If you are starting doing progressive delivery, if you are start applying these techniques that I explained you here, you are doing testing in production. And this means that production is not sacrosanct anymore because you're starting testing your production environment. And yeah, okay, if you tell to your manager, hey, we're going to test in production, probably will say no. I don't let you test a production environment, right? So it's something that it's the best way to promote this technique is saying we're going to deliver faster. Don't tell them that you're testing in production, because testing in production is it's really like the new thing, and there's a lot of techniques that you can use for testing in production. You can see here that some of them, the first thing that I want you to notice is that there is one column here which is named pre-production, which all these, like unit test, component test, coverage test, mutation test, smoke test, and so on. These are tests that you're going to run probably in your laptop or in your CI/CD system. Okay, it's just test that it says here that validates that the application is working correctly. But then you can see here that there are also 3 columns. These 3 columns are tests that are running in the production environment. You can see here, for example, in the deploy. Remember that I said that deploy and release is different. So here I'm saying, okay, when you deploy your application to production, but you are not sending public traffic yet, you can run integration tests. I know that some of you might say, oh, why integration tests? And let me do another question for you is, why are you running integration tests that involves a database against a in-memory database, a database that is empty, database that has a small number of records? It has not much sense to test it in that way. It has more sense to test it against the real database. So for this reason, I put it here, the integration test. And of course, there is top, compare, load test, shadowing test, and config test. All these tests are tests that you run when you deploy your application. Then there is the release, is when we are starting sending public traffic to this version. And you can see some of the techniques that I explained here, like canarying, there are canaries, filter flagging, and so on. And now there is a third column, this one. Usually we are not really into this. That is, when you release something, you can still continue testing it. Because we've got in our mind that, okay, we're going to test, we release to production, done. That's all. I'm going to start doing another thing. But that's not how the thing should work. Even though it's in production, you should continue testing your application. For example, profiling, multi-logging, chaos testing, and as I put it here, super important, monitoring. But because monitoring is what is going to tell you if your application is behaving correctly or not. This is an example of monitoring of, anyone knows exactly what is monitoring here? Any guess? No. It's number of plays in the Netflix application. So you can see that probably here is night, right? And this is during the work days, right? When we are working, in theory, we should not be watching Netflix. So it's here, and then time to time, people stop working and start watching Netflix. And as you can see, there is two lines, one that is red and one that is black. The red one is the version 1 of Netflix, of any service, in this case, the ones who start streaming a movie, and the black is the other version, okay? You can see that behaves more or less the same, which means that here they are doing a mirroring traffic, and they can say, oh, look, the new version is behaving more or less the same as version 1. So when a user push play button in Netflix, is getting the movie in version 1 and the same in version 2. So we're fine. But what's happened if this graph is different from version 1 to version 2? It means that there is some failures, and you have done, or you are integrated into your new version, some kind of regression. For this reason, I said, and I insist, that it's really important monitoring your application. That's the key point to make the progressive delivery be smooth. So how we can implement all these techniques? Because you can say, yes, that's nice, I like, but how I can implement this in Kubernetes, which is, we can say that it's like the de facto platform for deploying microservices. Okay, let's start with blue-green deployment. Can we do blue-green deployment in Kubernetes? Yes, we can do it. We can just need to create here, you can see, the Kubernetes service. There is the selector in service my pods. Basically, in the selector, you're putting a label here, and you can see that in the deployment, I say, hey, look, in this case, the label is app my node. In the selector, I put in service my pods. Okay, it's not the same, so this Kubernetes service is not going to send any traffic to this deployment. Then I can just, rewrite the label from the application. In this case, I'm saying, hey, change the app, in this case, my node to in service my pods, and then automatically Kubernetes will start sending traffic through this service to this new pod. Okay, so we can more or less implement it. How about canary releases? Yeah, we can still do it. I know that some of you say, okay, how can you can do? Well, here I'm doing just, creating replicas. That's the only way that we've got it in Kubernetes. You said, okay, I want to send 75% of the traffic to V1 and 25% of the traffic to V2. Okay, I'm just doing to create 3 replicas for V1, 1 replica for V2. And it works. And then you can just, reduce replicas from one place and increase replicas in the other one. It works, but it's very not useful. So, how about this? If I told you that we could have new objects in Kubernetes that we could directly define in this the percentage of traffic. In this case, I'm saying, look, I've got a service that is named recommendation, and I want to send 75% of the traffic to version 1 and 25% of the traffic to version 2. That will be nicer than, playing with scales. How about shadowing traffic? we cannot implement shadowing traffic in Kubernetes. Yeah, we can create another pod that that acts as a proxy, and then this proxy sends traffic to both pods and so on. But it's not something Kubernetes native. So how about this? If I could have an object that I say, look, I've got a service recommendation. I want to send the traffic to V1, but also I want to mirror the traffic to V2. That would be great, right? How about dark canaries? Sorry. We're talking about dark canaries saying, hey, depending on, for example, the HTTP header, I want to send the traffic to one version or to another version. In this case, I'm saying, I've got a service named recommendation, and if I've got an HTTP header, name it end user, and this end user is Alexandra, then send it to V2, but if not, send it to V1. You're going to do this with Kubernetes. You need something, right? Again, you can implement your proxy there, but it's not necessary if you could use this YAML file. And yes, you can use these YAML files, basically using Istio. Okay, Istio is a service mesh. I think that it's been quite this buzzword of service meshes has been around for a long time. So one of the implementations of service mesh for Kubernetes is Istio. Basically, Istio let you, among a lot of things, first of all, for example, intelligent routing and load balancing. That's what I show you. With Istio, you can start doing this routing. Not routing just, sending traffic to service A or service B, but also sending depending on, mirroring traffic or depending on HTTP header, wherever you want. You can do it with Istio. And of course, it implements a lot of more things, like, for example, observability. We've been talking all the time about monitoring and so on. With Istio, you've got all the observability and telemetry done for you. And I know that this is not the topic of this talk. By default, Istio, as you can see here, encrypts all the traffic of the mesh, which means that you can have service A making requests to service B. From the point of view of developer, you're doing a request using HTTP, but with Istio, automatically converts this HTTP call to HTTPS, making your inner communications secure, okay, encrypted. That's a really nice thing about Istio. But in any case, as I said, let's go with Istio and this intelligent routing and how Istio can help us for progressive delivery. Basically, Istio works because of the concept of sidecar container. Sidecar container, it's like a container that you put inside the same pod that does some work. In this case, you can see here, I've got the pod A, which is a JVM application. It's inside this pod. This is one container. And then I've got here another container that's in the same pod. Basically, this sidecar container, this one, which is the same as here and here, is intercepting all the network traffic. So every time that service A makes a request to service B, so A goes to B, it's not a direct call. It goes, service A makes a request to the sidecar container A. This sidecar container A sends a request to sidecar container B, which sends a request to the service B. And then the response does exactly the same path, but in the reverse order. Okay? This is how Istio works. This is why we do not need to implement anything on our own for encrypting the traffic or for routing the traffic, because here we are going to configure all these parameters. So now I need your help. So just scan this this QR code, which basically is an application. You see that there are some balloons. They're popping, and now in this case, it's going to be it's going to be, I think, or it should be, red balloons. Right? Everyone see red balloons? Yeah. Okay, I'm going to open it here as well. I think that I've got the link over here. So you can also, basically, So we can see all the same, okay? So in case that you're not using, you see here these red balloons here around. Then I've got here the application running. And what you can see, first of all, is that there is a front end and there is a back end. You see that all of them has two pods. Sorry, two containers. Each pod has two containers because one container is my business code, which is like print a balloon. And the second container is the sidecar container that I mentioned before. Now I've got here bubble backend v1, bubble backend v2. The v1 is one backend that produces red balloons. The v2 produces blue balloons. Now, you see that I've got deployed, the whole application is deployed. I've got for front end, backend v1, backend v2, but only two of these pods are released, the front end and the backend v1. The other one, the v2, it's in production, it's there, it's running, but it's not getting any traffic. Now, let's start playing a bit with this. I can just show you. Oops. What's backend? Source main Istio. Here I've got some, some YAML files. Let me show, for example, this one, virtual service. We can make, for example, now the v1 service. Yeah, we set bubble backend v1. No, that's not a mirror. Let me go with this. At the end, copy paste is what it works. Always. So you see here that it's just, okay, there is a service which is named bubble backend here. And then it said send 75% of the traffic to v1, 25% of the traffic to v2. So I'm going to apply this, this YAML file. There we go. And if you check here, okay, you will see that one. Apply. Oh, it's now. Now you will start seeing some blue balloons. 25% of the balloons are blue, the rest are red. And you see that I've not redeployed anything. My pods are still there running, but I've just changed it how the traffic goes. And I could change also to a 50-50. I guess that it's valid. Okay, I just applied this YAML. Oops, doesn't exist. Okay, there's no 50-50, but that's fine. Yeah, I mean, it's just a matter of changing the percentage. In this case, I'm going to put then 0, 100, which basically sends all the traffic to v2. So now there is no traffic to v1. So v1 is deployed but not released, and v2 is deployed and released. In fact, if you go here, you see that now there is only blue balloons. Now, let me show you another example here, which is timeout. Well, we could do a mirror or this one. Okay, now let me apply this. Kubectl apply -f this. And now I'm going to show you the YAML file in a few seconds. So you see that now in my case everything is red. In my mobile is blue. Anyone is blue in his mobile? Or blue? Some reds as well? Yeah, some reds as well, okay? Yeah, now I'm going to explain you why some of you see red, others blue. Basically, because if I go here and I show you this file, I'm doing the next thing. I'm saying, hey, look, if you're accessing with Chrome, then it's red. If not, it's blue. So depending on your browser, in this case, since I'm in Chrome, it was red, but in this case, it's not a Chrome, and so for this reason it was blue. So you see that you can see that my pods are still the same. I've not undeployed any of them 26 hours ago. So I'm not changing my code, nothing, and I'm changing how the traffic behaves from one place to another place. Now that we've seen this, let's go back to the slides. Again, no worries, we're going to play it or see more things. Because one of the most asked questions that I've got when I deliver Istio sessions was, can I automate this? So we're seeing here that I got it 100% of the traffic from red, 0 to blue. And then I applied another YAML file, which was 75%, 25%. I applied that YAML file. Then I could apply another YAML file, which is 50-50, and then another YAML file, 25-75, and finally one YAML file, 0-100. Okay? That worked, but people say, why I cannot make this move from one version to another happens automatically, instead of having to, to write all these YAML files and start, doing kubectl apply, kubectl apply, kubectl apply. And yes, it works, and it goes with one tool that's named Argo Rollouts. Basically, Argo Rollouts automates all this process, okay? What it does is what you can see here. It's you install Argo Rollouts in your Kubernetes cluster, then you deploy your service. One of the special things here is that you are deploying your service not with a deployment YAML file, but with a rollout YAML file. And then, when you apply this, we'll see now in a few moments, Argo Rollouts will start monitoring. You need to configure what is the monitor. In this case, for example, I can configure, for example, Prometheus. And Argo Rollouts is checking all the time the metrics of Prometheus. And if detects that the version 1 and the version 2 it's behaving in the same way, so it's, from the point of view of metrics, say, hey, look, the metrics are exactly the same, both versions behave more or less good, then start increasing the percentage automatically. Maybe you can say, okay, now increase from 90-10 to 75-25. You put this and automatically will move. And then it will start again monitoring. If it sees anything that goes incorrect, it says, oh, it's weird. V1 and V2, in terms of metrics, is not behaving in the same way. Then it automatically rolls back to the previous version. Okay, and this happens automatically. You do not need to do anything. How it works? It works in this way. You can see here, it's a simplification. And you see that now it's a rollout. It's not a deployment file. But keep in mind that it's exactly the same deployment format, okay, with the same specification, but with some additions. Basically, the addition is this strategy and all these things. In this case, I'm saying, look, I want to create a canary release. First of all, I want to, start sending 20% of the traffic to the new version, 80 to the old version, and wait for 1 minute. Then after 1 minute, you can say, okay, now I want to move from 50-50 and wait 2 minutes. If there is no error, everything is work as expected, then finish the release. And here you define which is the canary service and which is the stable service. So basically you are saying which is the old version and which is the new version, okay? And finally here you see that you're putting Istio. Because Argo Rollouts just rely on the other technologies to make this canary release process. And in this case, I've configured Istio. Okay, so wait, you can scan it, but let me show you first the YAML file that I'm using here. First of all, I'm going to undeploy the now I'm just undeploying the old version. Okay, so I'm just undeploying the bubbles example that it just uses Istio to now deploy another one, which is the one that is using Argo Rollouts. It's here. Let's deploy. Well, without metrics, which is faster. And / deploy. Okay, now I'm just, wait. I think that it's because I should run it from here. Scripts, not metrics / deploy. No. Maybe it's wrong. Dot. Okay. Let's go for. I don't want. It's without metrics, and let's do it manually. It's 2 directories beyond. See, it's 1 and 2. So it should be here. No. Here. Doesn't matter. That's the bad thing of having one computer for conferences, other for working home, that at home works. Then you move to the other one and it doesn't work, but the live, but it's going to be super fast at the very end. You see that I'm just, deploying the application. You can just have here watch kubectl get pods. So you can see that I'm not doing nothing really strange. Now also I'm going to deploy the gateway. Basically the gateway, it's the configuration of Istio to make the traffic go from the public cloud into the mesh. Then it's time for the front end. Wait, no, I'm here. Now it's the backend. Okay, so let's do the backend. Apply -f. I apply the service. Then it's the service canary. Remember that I said that should be 2 services. And then also let's create this, which basically, this one, it's deploying the version and releasing the version 1. So I'm going to run it. You see here, this is the, it's not that. Yeah, now here is the bird, wait, it's, okay, now the rollout, finally. The rollout here. kubectl apply -f, sorry, now. Okay, now, this is why I've got the script, to not having to do this manually, but basically here what I've done is just create the rollout object, okay, with the Bubble backend version 1. You can see it here. And here, from that point, is like a deployment file. As what I said before, that this is a special manifest, but inside you define the same way as a deployment. You put the replicas, the selector, the template, the container, the container name, the image pool policy containers, etc. It's all the same. Now, if we go back to the game, I'm going to refresh. It's not the same URL. Okay, get routes. Yeah, because I created another another gateway, so it gives me another another IP, well, another DNS. No. Why not? Why it's not working now? No, but that's not that one. It should be the same. Why not? Oh, wait. Maybe it's because it's getting, no. The HTTP /bubble/ well, if not, okay, doesn't matter because I don't know why it's not working, but we're going to see it here live, okay? So now you can see here that I've got V1 and the front end, and now I'm going to do a rollout, okay, of this version 1 to version 2, but using Argo Rollouts. So it's going to happen everything automatically. If I go here to Argo Rollouts, I don't know if the script is going to work without metrics rolling. Let me check. No, it's not going to work. No worries. I'm going to copy here. Now, here you can see that I'm doing a release that's going to happen automatically. First, it's going to send 20% of the traffic to V2. It will wait 1 minute. After 1 minute, it will send traffic, 50% of the traffic to the V1 and another 50% of the traffic to V2 during 1 minute. And then finally, it will remove the V1 and just send all the traffic to V2. So let's do a kubectl apply -f of the, oops, this. This one. Okay. And now you can see that a version 2 is created. Now, if I do, for example, kubectl argo rollouts, get rollout, and the rollout, I think it's named bubble. Well, I'm going to copy bubble backend. Oops. Minus this, you can see how we are doing the rolling update. Okay, you see this is the revision 1, which was the V1. Now this is the revision 2. In this case, it's healthy, and it's now it's paused. Okay, because remember that I said 75, 25, wait 1 minute, 50, 50, 1 minute, and so on. Sadly, we cannot see the bubbles, but you can imagine that now you will get from red to red and blue, and finally to blue. If we wait these 2 minutes, you'll see that eventually the V1 will be removed. So this revision 1 is going to be removed. That's super. Here you can see now the actual wait. It's how it works. The canary, it's paused. Then the image is the V1, which is the stable. And oops, here we'll see that in a minute, well, it's going to be a bit of more minutes, we'll see that the V1 will disappear. But in any case, since we cannot see the bubbles, now I lost the pointer. Okay, it's here. Let's continue, and then I will show you how the old pod has been removed, right? So let's go down. First of all, I've seen here a really simple example, right? Just bubbles, and even the bubbles didn't work. So yeah, things happened. But in a real world, I know that you've got the state, and the state is always hard. Okay, you can think, for example, in a shopping cart, right? You cannot say, yeah, I'm going to send 80% of the traffic to V1, 20% of the traffic to V2, and then, oh wait, yeah, now it's going to V1, then V2. Where is my shopping cart, right? It's lost. So I first of all recommend that you start applying all these techniques in stateless services. That's the easiest one. Then with time, let's change things to make your stateful services also work in this way. Basically, using infinite span, Redis, or any of this kind of in-memory cache. As say, step by step. Never say, hey, let's move to, everything to progressive delivery. You're going to fail. Just start small with just a service that you can manage, can control really well, and then start applying these techniques. Embrace GitOps. As I said at the beginning, the way to deploy into Kubernetes is not doing kubectl. Doing kubectl is like you were doing SCP in the past or SSH. It's exactly the same thing. So don't do that way. Just use GitOps. Remember that things is going to happen, right? As this quote says, if you haven't automatically destroyed something by mistake, you aren't automating enough. Okay, so of course it's going to happen bad things, but you're going to learn, and with the time you're going to succeed. Then, if you want to learn more about Istio, now about this demo, you can see here the links, and also in this QR code. If you scan this QR code, you're going to go to a developers homepage, developers Red Hat homepage, where you can download it books for free. Now, before let's see how now you only have, you see that the revision V1 has been scaled down automatically. I've not done anything. Argo Rollouts was just, checking the metrics. The metrics were fine. So we started doing this rolling update automatically till the V1 was out. So I think that we need to check if there is any question. Let me check. Room 6. There's no questions? QA, sorry. But no questions. That's, or I explained pretty well, or it's like, what the hell are you telling me? I don't understand anything. Okay. So, well, in any case, I will be around, so you can. Oh, my question has disappeared. Oh, okay. Oh, now. Oh, now it's. Oh no, there's a lot of questions. Okay. How does rollout detect an error condition to interrupt the process? Well, basically, it's basically when you define it. I can just, since we've got 3 minutes, look. Let me stop this. Let me go to scripts. Argo Rollouts with metrics. Oops, with metrics. Because I never remember exactly, it's the analysis template. Yeah, this one. Basically, you've got this. Where you say, look, my Prometheus is here, and I want you to check this. Okay, so you're checking this, this Prometheus query. In this case, is that the request is that there is the number of 500 error codes are the same. Okay, in this case, it's super simple, but you basically it connects to the Prometheus and just check from version 1 and version 2. It just sends this query to Prometheus and just validates if they are equally or not. Then another question is, does Argo Rollouts requires Istio? No. Argo Rollouts, it integrates with a lot of different, I think that it's here, the slide. Yeah, here. You see, it integrates with also with Nginx, with Ambassador, with Traffic, or with Istio. Even you can use none of them, but then you get these canary things of a scaling for example, you put, I want to put 75-25, then it scales 3 pods of version 1, 1 pod of version 2, and these kind of things, okay, if you do not use any. But it's not only Istio, it supports all of these technologies. Then, condition, that's from Istio, no. What is your experience with Istio regarding performance? Yeah. Well, let me answer that. Can I combine it with Helm? Yes, well, Helm at the end, yes. It just, you only need to put the YAML file with the kind rollout, and yeah, it works. I've never tried, but it should work. That's true. Then my experience about Istio and the performance. The truth is that when I've been, I don't have the numbers, but I know that some people in Red Hat has done a lot of performance tests and so on. they always tell me that it's not a big difference. It works slightly equally. But just keep in mind one thing, is that probably if you're not using Istio, you need to use any other piece to do more or less the same thing. So at the end, maybe you need to add a proxy in front of the services. This proxy is, what is Istio? It's just a proxy. So, of course, if you are not planning to use any of these techniques, then it's fine. But if you plan to use it, it doesn't matter if it's Istio or if you're using your own proxy. It's time. The truth is that, as I said, the performance, it's a question that I get it a lot of time. I just ask it to the Red Hat team, and all of them tell me, no worries. I mean, that we've done tests, and it's really a small difference. And that's all. Thank you very much. I'm around, so if there is any question, feel free to ping me.